everyone and welcome back to my YouTube channel. Today we'll discuss a carbylamine reaction for class plus 2 under the chapter amines. So it is the one of the most important reaction of the chapter amines. Repeated question of the chapter amines in CBSE exams. So what is this carbylamine reaction? It is also known as isocyanide test of amines. It is also known as isocyanide test of amines because the end product formed in this reaction is isocyanide. Alkyl isocyanide or even aryl isocyanide also formed. Alkyl cyanide and aryl cyanide both can be prepared by isocyanide test or carbylamine reaction. Second thing is it is given only by primary amines. This test or this reaction is performed by given by primary amines only. Secondary and tertiary are unable to react with the carbylamine reaction. What are the conditions of carbylamine reaction? The reagent is CHCl3, that is a chloroform, and the basic medium is required. So medium is here. Reaction takes place in presence of strong alkali, potassium hydroxide or sodium hydroxide. So what is the general format of this reaction? This is the reaction of primary amines. Amines are converted into alkyl isocyanides or aryl isocyanides depending on the nature of amine. If aliphatic amine is there, then aliphatic isocyanide compound is formed, and if aryl amines are there, then aryl isocyanide compounds are formed. So general format of this reaction is this is 1 degree amine, CHCl3 is chloroform, and this is strong alkali basic medium. So in basic medium, chloroform reacts with primary amine to form a alkyl isocyanide or a aryl isocyanide depending on this R. If this is aliphatic, then aliphatic isocyanide is formed. If this R is aryl group, then aryl isocyanide is formed. So after the reaction, we obtain alkyl isocyanide plus KCl plus water. If we understand this reaction on the basis of chemical bonding, then it is quite easy to understand. There is a electropositive metal potassium. If we balance it first, three KCl and 3 water molecules are the byproduct. On the basis of chemical bonding, we can easily understand it. 3 potassium are there, electropositive metal is there, it will react with the 3 chlorine. So 3 KCl will be 3 KCl molecules will be eliminated from air. Next, KH is a strong base. So base gives OH ions. So we have here 3 OH ions. Now this OH ion attract acidic hydrogen. In chloroform, this H is also acidic, as well as in amines there are 2 hydrogens. These 2 hydrogens are also acidic. So these 3 acidic hydrogens will react with these 3 OH hydroxide ions, resulting into formation of 3 water molecules. So these 3 hydrogen react with the 3 hydroxide ion, resulting into the formation of 3 water molecule. So now what we have left? Alkyl group, nitrogen and carbon. So they will combine to form a RNC, isocyanide. as the reaction is completed, there will be a foul smell of isocyanide. So this reaction is characterized by release of foul smell. Foul smell will be there, and that smell is of isocyanide. That's why it is called isocyanide test of amines. Even it is a name reaction also. It is also called as Hofmann isocyanide synthesis. So carbylamine reaction is also known as a Hofmann isocyanide synthesis as well as a isocyanide test of amines. And this test is given by primary amines only. Secondary and tertiary are unable to react with the chloroform in presence of basic medium. So end product of this reaction is a isocyanide. That's why it is also called a isocyanide test. Then we understand it on the basis of chemical bonding, but what is the actual mechanism of a isocyanide test or a Hofmann isocyanide synthesis? Now let's move to mechanism. Mechanism is quite easy and it will give you a clear idea how this reaction takes place. So now we have a mechanism of this reaction. Actually, this reaction is initiated by the reaction of chloroform with the basic medium. This is a chloroform, and due to high electronegativity of chlorine, these electrons are slightly attracted towards chlorine, resulting into ease of cleavage of this bond. This bond can be cleaved easily, means this H is acidic, and we have basic medium KOH. So this base will give hydroxide ion. This will interact with this hydrogen, and these two electrons will move towards carbon, resulting into formation of a intermediate product. So first here water is formed, minus H2. If this H is attracted towards OH, then these two negative charge will come on carbon and hydrogen positive is there, so that's why water is formed. So carbon negative, as well as these two electrons will move towards carbon. So now we have this structure due to increased charge density on carbon, and we know chlorine is a good leaving agent, so it will take its electrons and relieve from here, move from here, and it reacts with the electropositive metal potassium, and this negative charge will be vanish out as these electrons will be taken by chlorines, resulting into the formation of KCl. So one molecule of KCl is also formed. So now what we will have? We will have only this intermediate. Now this is the major intermediate of a carbylamine reaction. It will attack with the attack on amines. Now if we understand it, around carbon we have only 6 electrons, 2 electrons in this bond, 2 electrons in this bond, and this one lone pair. So octet is not completed here, so it is an electron deficient compound, means electrophile. Octet is not completed, around carbon only we have 6 electrons, so it is an electrophile. Again understand, this negative charge is vanished out. Why? Because these two electrons are taken by chlorine and it will react with the potassium, so this negative charge will vanish out. Now we have this electrophile. This is known as a dichlorocarbene. Carbene means having two free electrons. Seems like a lone pair. So this electrophile is generated by the reaction of chloroform and KOH. Now it is electron deficient, and in amines we have a lone pair on nitrogen. That will nitrogen will give lone pair to the dichlorocarbene, resulting into the formation of a intermediate compound of amine and dichlorocarbene. So next is dichlorocarbene is electrophile, electron deficient. This is electron rich, lone pair is there. So this lone pair is given to this carbon, resulting into the formation of bond. Lone pair is transferred from nitrogen, so nitrogen will show positive charge, and lone pair is transferred to carbon, so carbon will show negative charge. So it is the intermediate product. Now reaction takes place in presence of basic medium, so one KOH molecule will remove this hydrogen also. So under the impact of basic medium KOH, it will give hydroxide ion. This hydroxide ion will abstract hydrogen from this intermediate. So these electrons will move towards this bond. These electrons will move towards this, and due to increased charge density, this chlorine will be again playing the role of a leaving group, leaving agent. It will eliminate from here, it will remove from here, and it will react with potassium. So another formation of KCl minus KCl, and one water molecule is formed more minus H2, resulting into the formation of a double bond here. Now remaining structure is this, still positive charge on nitrogen and negative charge on carbon. A double bond is formed by shifting of these electrons. So next, again under the impact of KOH, again this, it will give hydroxide ion and it will abstract hydrogen. So water is formed again minus H2O. So these the electrons of nitrogen hydrogen bond will move towards this carbon. Again due to increased charge density, chlorine will play again the role of leaving group. It will eliminate from here and it will react with the potassium. So formation of KCl. KCl is also eliminated. So again there will be the bond formation. So remaining structure will we have so carbylamine reaction has taken by this mechanism, electrophile generation by the reaction of chloroform with the basic medium. So you can understand it on the basis of chemical bonding as well as a real mechanism, how reaction proceed by the generation of electrophile dichlorocarbene. Right, quite important for CBSE exam, most repeated reaction. I hope you will understand it. Thank you.